Hi everyone, and welcome to our video on using SOH CAH TOA to help us find the trigonometric ratios given a trigonometric ratio. Okay, so I said ratio, they might say function. So it says use each given trigonometric function. So they might say trigonometric ratio instead. The reason for ratio is because, well, look at our answers from the previous video. They're all fractions, and fractions are ratios. So they might say that instead, based on this given value of secant of theta equaling 5. All right, so whenever they say to find these trig functions, kind of like above, instantly I'm just going to get my table ready and then I'll look back at the information. So sine of theta needs to equal something, cosine of theta needs to equal something, tangent of theta equals something, and then leave some space, get the reciprocals, cosecant of theta equals something, secant of theta equals something, and then cotangent of theta equals something. Okay, and I'm going to even just box all this off. There we are. Okay, so they'll give us this information. So notice they give us secant of theta, and that's equal to 5. So I can put that in the table right away. And I would also automatically have cosine. So this is 5 over 1. So if you ever have a number, you can always put 1 under it to help with the flipping. So we know cosine of theta is 1/5. Okay, so I'm just going to rewrite that. So we don't need to show the 1, just the box all answers, even though we already had that. Okay, so anyway, so without even doing any really much else, we know the reciprocal property can give us cosine of theta right away. However, one of the other things they mention in this is they say that sine of theta is less than 0. Okay, so actually I'm going to mark that in blue. So this is trying to help with the quadrant. So if sine of theta is less than 0, that also means that sine of theta is negative. Okay, and we can mark that right here, negative. Cosine of theta we see is a positive number, positive. And then we could figure out the sign of tangent just based on this. If sine is negative and cosine is positive, remember tangent is your sine answer over your cosine answer. Okay, so and we can put that, let's put that in right here. I'm going to try to put it in a little smaller. Sine of theta over cosine of theta. And then might need to erase, sorry, but let's see if we do. But if the sine of theta is negative and the cosine of theta is positive, a negative divided by a positive should be negative. Okay, so that way we can get the signs of all of them. Okay, so we already know that information right away. The other thing we could have done with this, let me keep it in blue actually. We could have said, well, if sine of theta is negative, I know I'm somewhere down here. And then if cosine of theta is positive, again, we can mark this. Secant of theta is positive means cosine of theta is positive. That must mean I'm somewhere over here. And so again, we could break it down and say we must be in quadrant 4. Okay, which matches these signs anyway. So sine of theta is negative, cosine of theta is positive, tangent of theta is negative. Yeah, that's what would have happened in quadrant 4. Okay, so a little bit of preliminary work before we dive fully in. All right, so now we know the quadrant. We just have to really make sure, so even underline these, just make sure you get your signs on at the end. Because otherwise, what we're going to do is I'm going to take the cosine of theta, and I'm going to use SOH CAH TOA. I'm using it with the cosine part. So if cosine of theta equals 1 over 5, just to mark it right here, I could draw a right triangle and put, so just a generic right triangle. You could draw it differently if you want, but this is the one that I usually draw. So from here, I know that this would be the opposite, this would be the adjacent, and then the longest side is always the hypotenuse. Well, this is saying your adjacent is 1 and your hypotenuse is 5. So we know that this is 1 and the hypotenuse is 5. Which means we could figure out the opposite. Okay, so our opposite, let's go ahead and keep this in red. By Pythagorean's theorem, we know the adjacent side squared plus the opposite side squared should always equal the hypotenuse side squared. And so when we plug this in, we would have 1 squared plus the opposite side squared, which we're trying to find, equals the hypotenuse side squared. And then we go through and solve this. Okay, so 1 squared is 1, plus the opposite side squared equals 5 squared is 25, we can subtract the 1 over. So if we subtract it over, I'm going to say we just do it and we have 24, and then we can square root both sides. Remember to do plus minus. However, I already have the signs marked over to the side there, so I'm just going to put a check mark, check, or put an arrow, so whatever. I'm showing that my signs are already marked, so I'm just going to keep this positive because I'm looking at this right triangle as a physical geometric shape, and I'd rather just look at the triangle as all positive values and then let the signs be determined based on the information I've already marked. Okay, so I'm going to say that this is, I'm choosing the positive. So we have the square root of 24. Now we can't do that square root. However, we could simplify it. Okay, so the square root of 24 is 2 and 12. 2's prime. 12 is 2 and 6. And then 6 is 2 and 3. So there's its prime factors. So we've got 2 times 2 times 2 times 3. And then, well, 2 times 2, let's highlight that. 2 times 2 is 4. We could do that square root. So the square root of 4 is 2. 2 times 3 is no special square root. It's just 6, still under a square root. But again, square root of 4 we could do, that's 2. And then square root of 6 is left over. Okay, so our opposite side is 2 square root 6. Okay, so there's all of our sides. And then now we'll use this right triangle and just plug in our sine of theta and tangent of theta. Okay, so let's get our sine of theta. So sine of theta is opposite over hypotenuse. Okay, so we have sine of theta using SOH. So just a reminder, sine of theta is opposite over hypotenuse. The opposite is 2 radical 6, and then the hypotenuse is 5. And then I look back and say, oh, don't forget, this should be negative. It said it was negative from the very beginning, so put a negative in. There we go, that's it. So there's our sine of theta. Okay, and then tangent of theta, I could use these two answers, this one and this one, to plug into that big fraction. However, I think it's better to just do tangent of theta equals opposite over adjacent. Okay, so notice you have different ways to go about it. My opposite is 2 radical 6. Okay, so I'm gonna cross that out at this point and just say I'd rather just use SOH TOA for this answer and skip that step. Okay, so I'm using my right triangle. I have the opposite is 2 square root of 6. I have the adjacent is 1. And then again, I said, well, it should be negative. So let's write it like that. Okay, and I'm gonna, because I'm a little out of room, we don't really need the 1 down there, but I'm gonna keep it there for our final answer anyway. Okay, so that's that. Notice, okay, so I scratched it out, but real quick, if I did say, how about I do the sine of theta over cosine of theta, just to see it. So the sine of theta answer was negative 2 radical 6 over 5. Our cosine of theta answer was 1 over 5. Every time this will happen, these denominators cancel. And then notice we're left with negative 2 radical 6 in the numerator. And we're left with 1 in the denominator. So it's the same thing. Okay, so you get the same answer, except the triangle was a little faster. Okay, anyway, now that we've got our answers for sine of theta and tangent theta, we do have cosecant of theta. Cosecant of theta is to flip our sine of theta answer, and then I'm just keeping the negative in the numerator, and then we would need to rationalize it. So let's multiply both the top and bottom by square root of 6, and then that gives us, I guess I shouldn't have drawn that big box there. We'll come back. When we rationalize it, we have negative 5 radical 6 over, this is 2 times 6, so that would be just 12. Okay, so these two became just 6. 6 times 2 is 12. Okay, now that should be enough space. Okay, and then our cotangent of theta is to flip the tangent of theta answer. Here's where that 1 in the denominator is kind of nice, because we can see, oh yeah, it flips and now is in a numerator. Still negative, and I just put the negative up top. And then just like what we did with the cosecant theta answer, we need to rationalize. Okay, so then we get negative radical 6 over 2 times radical 6 is 12 again. Boom, done. Okay, so there's our final answer for that. Okay, so that is using SOH CAH TOA given a trig function. So they might give you a triangle right away, like the previous problem. They might give you a trig function. Either way, we can work with them both, make a right triangle, and use that right triangle to find your ratios or functions, all of your trig functions. Okay, so that's it for now. Thank you for watching. If you have questions, please let me know. Otherwise, see you next time.